So for tonight, we have deep visibility logging from distributed microservices, and I'll talk about a lot about what that means. For the most part, that means we're going to be talking about serverless logging and the nuances of serverless logging. I'm very pleased to be joined here by Jerry Dixon, as Stephanie said, and by Josh DeMuth, AWS Solutions Architect. And Josh will dive deep into AWS. So, glad to be partnering with him. And Jerry is going to be my partner for the demo that we're going to be showing today. And we'll talk about just the importance of logging and some common pitfalls and best practices, and even compare traditional application logging with serverless logging. And then, like I said, we'll dive deep into serverless logging and show a demo. So really quick, introducing myself, I'm Aaron Lieberman. I'm the Cloud Practice Manager at Big Compass, where we primarily focus on AWS. I started off actually with web methods early on in my career, and then used MuleSoft for a good portion of my career. Now for about the last 5 years, I've used AWS as the primary technology of the implementations that I use for my clients. And I tell that story just because I sort of started off, in the web method space, developing large monolithic applications. And developing those large monolithic applications, you didn't really have to worry too much about logging. Logging was sort of built into the platform, and you could log all your server logs, off to one server. But now with AWS and the distributed microservices approach and the serverless approach, you really have to put a bit more focus on logging. You can come up with good logging solutions, but you have to put that extra focus on it. So it's very prevalent in my more recent integrations and implementations that I've done. I'm an AWS certified solution architect and developer, and enough about me. Real quick about Big Compass. We are a consulting company and a partner with AWS, and we specialize in integrations and related technologies. So we specialize in MuleSoft and Boomi and AWS, and that's the practice that I lead. And we have specialties, especially in the serverless world with AWS Lambda and API Gateway and DynamoDB. And we're just really passionate about serverless here in the cloud practice at Big Compass. I truly think it's the trend of the future, and much of the value that we'll deliver through integrations in the future will be built on serverless technology. So very passionate about serverless. If you ever want to talk more about serverless with me, like I said, feel free to connect with me. And here at Big Compass, we build connections. And we build connections between systems and applications. That's the integration side of things. But we also build connections between people and ideas. I think that's even more important than normal, in COVID times, where we want to continue to put a focus on connecting with our peers. And that's you. So thank you for joining. All right. So let's talk about the importance of logging. And logging is so important for many reasons. But first of all, I like to ask the question to clients who question whether we need more focus on logging, or people who just like to talk to me about logging. Can you imagine a system without logging? And I like to present that scenario because it would be one where it'd be almost impossible to debug or support or find out what's going on in the system, or even on a happy path to find out what happened with a particular transaction in the system that you're creating. So I like to think of logging as giving you the three pillars of the ilities. So we have visibility, traceability, and supportability. Okay, and logging gives you visibility into your system. So now we're starting to answer that quiz question from the previous slide. And visibility is the backbone to any system. You need the visibility into your system to be able to tell what happened at any given moment. And logging the right amount of information makes the system visible to the user or the support user or the developer. And traceability now builds on visibility. And that traceability allows you to trace one transaction or request from end to end. So you need the visibility for traceability, but traceability gives you the right amount of logging so that you can track that transaction through step A, B, C, and so on and so forth through your system. And that's usually accomplished through request identifiers. And you can do that by logging across applications to a centralized target. And you can easily do that by putting a unique ID for all logs for one particular file or request or transaction in your system across your microservices. And then supportability. So supportability relies on visibility and traceability. So now we're seeing the building blocks of these ilities. And I've seen systems where the number one cost is the cost to support your system. And I've come in and done implementations where we've reduced that cost by doing a logging implementation, and we've reduced that cost by 90% just by doing a logging implementation. So think about how much money you could save by just focusing on logging up front, right? And you get that great supportability of your system if you do so. And then debugging. So debugging also relies on visibility and traceability. And debugging is great for developers, right? I'm sure you've all been there where it's extremely hard to track something down and you're trying to find a needle in the haystack. Well, logging is the first step to finding that needle in the haystack. So that's why we're talking about logging. Let's talk more concretely about logging pitfalls and best practices, and then we'll talk about serverless. So some logging common pitfalls. No design for logging. I've seen this quite a bit because from what I've seen in my implementations, there's two key items in an integration implementation that oftentimes go forgotten. One is API security. You can go to production without API security and leave an API open to the world, right? And the other we're talking about today is logging. So many people want to move forward without these potentially just because you want to move really, really fast. And we've probably all been guilty of this. But those are two core pillars of any implementation. So design for logging, right? Lack of standards. Lack of standards is a huge one. Developer A might be logging in format A. Developer B might be logging in format B. And then when you combine those logs on a centralized system, now you're trying to read, it's like reading two different languages. It's hard to read. Hard coding. Hard coding particularly comes into play and is a common pitfall in error handling. So if you think about maybe a try catch block, in your catch block, if you're hard coding error messages, you'll never actually find out what the stack trace was or what the error message was or the detailed description of that error. So try to avoid hard coding. Lack of connective traceability or lack of request identifiers. And request identifiers really provide you that traceability. And so if you have, let's just say 3 microservices in a chain, and you don't provide a request identifier across those 3 microservices, you're going to be wondering, okay, what events occurred in microservice A, what events occurred in microservice B, what events occurred in microservice C, and how do they all relate? You won't have that relation between all of those different Lambdas in AWS. And then logging payloads or sensitive data. Huge common pitfall. I've seen people logging, entire payloads with sensitive information and filling up logs with huge payloads. So try to only do that at a lower log level, maybe your debug log level, or try to avoid it at all, especially the sensitive data. Don't log any plain text sensitive data. And logging too much. That's exactly what I was just talking about. Logging full payloads, for example, that might come in and be 5 megabytes in size. You're going to fill up logs really quick and pay for it, literally pay for it in dollars. And logging too little. You don't want to log too little because then you won't have the visibility into your system. And so the outcome of filtering out all these common mistakes is that you start to organize. And organization leads to standardization. And that's ultimately what you're after, because once you standardize, you can start to stabilize and optimize your system, and it really unlocks potential. So I want to bring up a couple logging common pitfalls. And if you're paying attention, you might be astute enough to notice the common pitfalls in the first and the second picture here. And I want to, point out again, or feel free to come off mute or put in the chat. Can anyone note what the logging common pitfalls are in the top picture? Or feel free to, again, come off mute or put them in the chat. Passwords in the clear in the bottom picture. Yep. What about the top picture? Give it one more second. It seems okay at first, right? It seems okay at first, but looking into this first picture in black, you really actually have no idea what request was made, because all you're getting is the metadata of a 200 and a 400 and really a timestamp at which that request was made. You see the IP address is abstracted, so it must be coming in, maybe from a proxy. You're not getting the actual IP address. You're not getting what client made this request, so you can't trace this back to someone or something. And that forces you to guess. It forces you to guess based on timestamp, forces you to guess based on status. So if a client consuming your API were to come in and say, and by the way, this is an Nginx proxy log. And so if a client were to say, hey, I made this request at 13:46:25. Well, the problem in there is I have two requests actually at 13:46:25. I need some more metadata about that request to be actually be able to tell what happened and what client made what request. So think about the metadata that you can log along with your logs. And then in the second picture, so it's good metadata logged, nice format. Sort of, it's pretty readable in the second picture, but of course, sensitive information is logged, right? So it's so common. Beware, I have it highlighted in red, and it's pretty obvious, but it does happen all the time, and it's easy for it to happen because unless you're inspecting your logs, it's easy to log an entire payload. Okay, so let's get into the best practices. So standards is the message for best practice. I already mentioned that in the logging comment pitfalls, but whatever standards you create are great. Whatever standards you create are good for you, whether it's JSON or key value pairs or other formats. And as long as you standardize, you're going to be better off in the long run. So standardize your logs first and foremost. And informative messages. So that gives you visibility into the system. It enhances your debugging, enhances your supportability, and you can typically do this before and after external system calls. You get those informative messages before and after a database call, for example, before and after an external API call, for example. And that allows you now the visibility and the traceability into your system. If you give informative messages that tell you what happened at step A, B, and C, you can now tell that story and easily debug and support your system. And request identifiers. Request identifiers, like I said, allow you to trace that transaction from end to end. So attach a single request identifier across all of your microservices and across all of your logs. Just bake it into your logging schema from the start, and it'll help you again in the long run. And it also allows you to calculate latency if you really wanted to. If you're not already calculating latency or using something like X-Ray, for example, in AWS, request identifier will allow you to do that. Dynamic error messages. This was one of the common pitfalls. Don't hard code your error messages. In catch blocks, if you're coding, you can put in a dynamic error message. So put in the description of your error, maybe even your stack trace at a lower log level. And persisting logs to an easily accessible system. This is key for a lot of people. And Josh will talk about this more. I'll talk about this more as well. But some ideas there are CloudWatch, right? Centralized system for all your Lambdas logs. Another one would be Splunk. Another one would be Loggly, and the list goes on. And log at appropriate levels. So oftentimes you'll log at an info level, but in your error handling, think about logging at an error level, and think about enabling debug logs, for example, or even trace logs, and logging an appropriate amount of data. So the antithesis of what that common pitfall was, don't log too much or too little, log before and after. What I like to do is log before and after your external system calls. And standards is really the message here. Again, standards unlock the potential, and they unlock the ability to stabilize a system. If you know what's going wrong with the system, you can make improvements and make feature requests and so on and so forth, and put those stories in your backlog. And they allow you to optimize your system. Again, you can make those feature requests and ultimately stabilize your system, but then start to figure out maybe what is the slow part in my system if you didn't have visibility into that before. And so let's look at just a couple of examples here. So in the top left, in the black here, you see pretty good logging format. Maybe some metadata is warranted here, but this is a pretty good example. You see request ID. This same request ID comes up with 3 logs when you search for it, and it tells you exactly what happened. It accepted the request, it processed the request, and then it sent the HTTP request successfully at the end, and it's finalizing the flow or your service. And then in the background there, again, we're doing the same thing. You're searching for one request ID that picture is of the elk stack, and it pulls up all of the logs related to that request ID. Jerry will show much more of that in the demo. So let's compare traditional logging to serverless logging. Traditional logging is typically single application focused, and logs are coming from a single source. So it's very nice. It's like an assembly line. If you look at the icons on the bottom, it's like a nice assembly line of logs all going from a single source to a single target. So it's those predictable logs based on user traffic, and it's typically written to a file or to the console or to a single system maybe. And like I was saying at the beginning of this, maybe back in my web methods days, I didn't really have to worry about logging because all I was doing was logging, to the default server logging, because I was sort of dealing with monolithic applications. But now in the serverless world, it's multi-microservices focused. And I don't know if that's an actual word or term, but you have many different microservices that you're building and creating. Your serverless footprint grows so easily. And so you have logs coming from many distributed microservices. And that makes logs very unpredictable. And it's really based now on your growing serverless footprint instead of user traffic. It still is based on user traffic, but you have a growing serverless footprint that will probably add features and functionality into your system. And so you get this spaghetti mess of logs. And it's typically, I would advise at least, written to a centralized logging tool or system, because you have so many different microservices out there. You have a need now to centralize those logs. So real quick example architecture, right? I've oversimplified this sort of on purpose, but if you have an API and a processing layer living on EC2 and a client making requests to that API, you can from EC2 log out directly to Amazon's Elasticsearch. Very simple, very straightforward, nice and clean, right? But let's contrast that now with the serverless logging architecture. And you see now how much more complicated this can get. So maybe you've broken up that EC2 into 4 different API gateways and various different Lambdas. Those Lambdas are logging out to CloudWatch. And then from there, you're ingesting logs into Elasticsearch. This could be a great architecture. And this can work for a lot of people. But the thing that you have to do now is worry about that logging in all of your Lambdas. And Josh will talk about ways to mitigate that. And I'll mention, a way to mitigate that soon, so you don't have to repeat code in all of your different Lambdas. So it's messy. It can be a spaghetti mess. And you can mitigate that and maintain it well if you plan for it. So some of the pain points that you see with serverless logging. So again, why are we talking about this today? You have many distributed microservices that communicate with each other, and that can run into code replication. If you don't design for that and plan for that, you can have developer A, B, and C all coding basically the same thing into your Lambdas, and you want to be able to abstract that out into one reusable logging service. And we recommend to add a logging framework as a dependency, so you're minimizing replication. And that's exactly what we're going to show. That's what Jerry is going to demo. We've created this reusable logging framework, actually, that you can use and clone after this presentation. And again, otherwise that leads to code replication if you're not using a framework. And maybe you even load that into a Lambda layer. And that's alluding to, again, a bit more of what Josh will actually talk about. Log scaling. There's a lot of logs going through your serverless microservices. And you need to be able to maybe batch up your logs to ship them off in batch to your target. Maybe it's Splunk, maybe I'm not going to talk about CloudWatch because that's automatic with Lambdas, right? But if you are going off to a centralized logging system that's outside of AWS, you might want to think about batching, or you can send those off and queue them up to guarantee delivery. And you can really produce a massive amount of data. So you even want to think about maybe the cost that you're going to be incurring in something like Splunk. And then there's minimal logging frameworks that work well for serverless implementations. I'm curious how many people here have worked with serverless implementations in the past and actually had a nice, elegant logging solution. It's been few and far between for us, and then we actually started using this logging framework that Jerry is going to demo here at the end to be able to solve for this. And default target for AWS Lambda is CloudWatch, and that can be great for console logs. And there's times where CloudWatch works, and that can be a great approach for your organization. Especially if you're all in on AWS, you can tack on CloudWatch Insights on top of that, and again, that can be a great solution for you. And there's also many times where organizations have a mandate to centralize on a logging tool such as Elk or Splunk, or one of the other various logging tools that are out there in the marketplace. And in those times, maybe your organization mandates it, or you already have a pre-existing implementation on those tools. You want to be able to easily log out to those centralized systems from all of your various different microservices. And that's where the framework comes in. And so some must-haves. So first of all, before reading the must-haves, The best practices that I already mentioned for logging are only amplified with serverless. You only have to put more focus into those on serverless. The standards that I mentioned, right? The request identifiers, all are amplified with serverless. And so you need to take time to properly log from each AWS Lambda and put extra focus on it. And again, I recommend to abstract that into a reusable framework so you don't have to worry about that in every Lambda's implementation. And so a centralized logging target is an absolute must. You either need to have CloudWatch running with great CloudWatch insights, or ship those logs off to something like Loggly or Splunk or Elk. A reference ID to reference across microservices. This is that request identifier, gives you the traceability that I talked about earlier in the presentation. And this allows you to say, okay, let's say you have an API request and 3 Lambdas sitting behind that. It allows you to trace that API request all the way through those Lambdas and back out to the client. An execution ID to reference the individual AWS execution, that has been extremely helpful for us, to determine things like duplicates, and to also attach an individual Lambda's execution ID along with the reference ID that would be a bit more global across your microservices. And then log metadata about the process. So you have tons of metadata, maybe again, it's coming in from an API gateway. You log the size of the body, maybe the size of the headers even, just some metadata about the process. What client is it coming from? Things like that, just to give you more visibility into your system. And now some targets, some options. There's plenty of options out there, and there's pros and cons to each approach, really. And as stated before, CloudWatch can be a great option, and tacking Elasticsearch, AWS's Elasticsearch on top of that can be a really great option, or even CloudWatch Insights. But there's Splunk, and there's Loggly, and there's Elk, and Elastic, and Graylog, and there's a database even as an option. And X-Ray gives you great traceability and visibility in your system. So there's so many options in the marketplace. I don't think it's the tool that will make you succeed or fail. It's your implementation of that tool. So plan for your logging, and I truly believe any one of these tools can work. So what does that look like in a modern environment? So a modern environment might not be completely serverless, right? It also might not be 100% monolith. It might be a hybrid implementation. So it has many different components. It can be messy, and it's rare that a system is 100% this or that. Almost always these days, the system is taking a hybrid approach. And so you might have an iPaaS implementation combined with a serverless implementation, like MuleSoft with AWS, for example. You might have a legacy system built on a Windows VM, Perl script, right, combined with AWS Lambda. You might have EC2 combined with Lambda. There's an infinite number of combinations, really. And in practice, you might have even larger of a spaghetti mess, that looks like this. So this is what a modern system really might look like, especially with the trend in the industry right now, where many people are migrating to the cloud and even migrating to serverless. You might break up certain components of your system or your application, migrate that to serverless first, and then somewhere along the way, you're going to have a hybrid approach. So you might have 80% serverless, but you might decide to keep a few components on EC2 or a few components on MuleSoft, for example. And you can log from serverless or Amazon EC2 or MuleSoft, and you want to be able to do that in the same way every time, which can get complicated. And so you need to think about the producing side, and you need to think about the subscribing side or the receiving side of your logs. So on the producing side, you don't want to be able to replicate that log producing side to all of your different applications, your MuleSofts, your EC2s, and your Lambdas. You want that sort of centralized framework that can scale and throttle with you. And then on the subscribing side, you want to think about the one centralized target. And so that's exactly what we did. Jerry will demo this here in just a few minutes. We created a logging framework that is ready for your use. We'd love for you to go and clone it on GitHub. And on the producer side, it doesn't necessarily care about the consumer. It's decoupled from the consumer. So you can produce logs out to really any target that you want. There's some built-in log producers that we've included that you can use. And you can just include it as a dependency directly in your applications, including EC2, including MuleSoft, including Lambda. You can even install it as a Lambda layer. And that allows you to send logs off to an arbitrary number of targets. And you don't necessarily need to know about what the log ingestion system is at that point. So again, you can have 4 API gateways up there with various different Lambdas. You can have an application running on EC2 that talks to those APIs, and MuleSoft also down there. And you have different ingestion points. One can be API gateway for the consumer side, and one can be SQS for the consumer side. And maybe you split those out between internal and external type of applications. And so now you start to sort of distill this spaghetti mess of this hybrid architecture down, and you've replicated basically a framework or a dependency to all of those different log producers, and made it quite a bit cleaner. And you've created one reusable area that if you need to make changes, you can do that in one centralized location. And you sort of enforced standards to all the developers who are working on your Lambdas and your EC2s and your hybrid environment. So with that, I'm excited to dive deeper with Josh and then get into the demo with Jerry. And Josh, I'll let you go ahead and share your screen.
Cool, thanks. So I'm gonna go on camera just really quickly. Hey, my name is Josh Demuth. I'm a PSA at Amazon Web Services. It's great to be here with you all today. It's nice to see people across the globe. And similar to Aaron, I actually worked with web methods a lot. And my introduction to the cloud was migrating a very complicated web methods system, or I guess being a part of a wider team to migrate a pretty large web method system to the cloud. So I've basically been in love with the cloud since then. And today I get to talk about one of my most favorite services that we offer. So let me stop the video and share my screen. So just to kind of extend what Aaron has been speaking about, I'm going to do a little bit of a deeper dive into Lambda. All right. So like I was saying, Lambda is by far one of my favorite services. So first we'll start by discussing what makes up a Lambda function, and then we'll talk about how Lambda layers can help solve some of the complexity that Aaron mentioned before. I know that he mentioned that a little bit as well. And then we're going to touch on 2 of our newest Lambda features. So we'll discuss how to extend Lambdas even more with Lambda extensions, and then have more visibility with Lambda Insights. And I'll finish up by discussing 4 of our recent Lambda related announcements from reInvent from last week. All right, so first, a Lambda function is made up of 3 main things. So we have a handler, which is the starting point and pretty much where your function starts once it is invoked. And then we can have an event object. So this is the data that's passed to the Lambda at start time. So for example, maybe your Lambda is being invoked from an S3 put notification, for example. So that event could have information about maybe the S3 bucket, for example. And then finally, we have the context object. So this gives a little bit more info about the Lambda invocation, like the request ID and maybe the log group that you can kind of grab and interact with if you need to. And then here's just a really small example of pretty much the most basic Lambda function that you can have. All right, and Lambdas can be written in several languages, but they typically follow a pretty similar process. So you would have your entry point handler, and to avoid having that function get too large and complicated, you would start to use sub functions as well. Sorry, please bear with me. I'm having a slight issue with my computer. Okay, so in this pseudocode, we are calling a subfunction based on information received in the event. So for example, if your Lambda is triggered from SQS, then maybe you can parse that event and perform logic depending on a certain condition. And having sub-functions help make the code a lot cleaner and easier to read. So again, that's very similar to, just a traditional application, is that you don't want to put everything inside one big function. Lambda functions will grow in complexity as your business logic grows. Again, very similar to legacy applications. So you could potentially have dozens of sub-functions split across multiple files. All right, so now, sorry, I'm having trouble here. All right, so yeah, it can be a lot more than just business logic as well. So, all right, so now we could have something like this. So the actual conditional logic specific to this Lambda is just one small piece. And we have a lot of this extra code that we need in order to satisfy all the requirements. So essentially, there is just a lot of potentially duplicated code there. So let's assume that we have an API-based workload that has many different paths, and each path could call maybe a different Lambda or have some type of different logic within a shared Lambda function. And let's also assume that each path needs to interact with either a database or use similar keys or other configurations from external services. So whether that's like DynamoDB or RDS or just some other service. All right. So we could run into a scenario that looks similar to this. So let's just assume that each one of these is a different Lambda function, just due to maybe having different business logic. So you could absolutely have different Lambdas behind the same API gateway, for example. So this could create a scenario where we have a ton of duplicate code. So each time that you need to talk to the database, you would have code in your Lambda to be able to do this. So that means that each function could have very similar code. And for example, like as you're connecting to the Dynamo table, whether that is the same Dynamo table or not, the actual code itself to create the connection, for example, would be similar across most of the functions that you have. So ideally, we would want to convert into something more like this, where we could write helper code one time and then have each Lambda call it. It would look like this, where we could have all of our helper function and functions and all of our shared logic essentially separated, so it doesn't have to be duplicated into each function. So that is why we created Lambda layers. So it lets functions easily share code. So you upload your code once and it can be used by other Lambda functions. So this is very similar to importing regular Lambda code. So as long as you can code it within a Lambda function, you can most likely put it into a layer as well. So this simplifies the deployment process and allows separation of responsibilities. If you would want maybe separate teams, coding out your logging functionality versus your business logic, for example. And this really allows your developers to focus on business logic versus having so much overhead in each individual Lambda. And there's also support to pull in layers from others. So for example, if a company like Big Compass, if they wanted to give you their login framework, as a Lambda function, then you could potentially expose that as a Lambda layer, and another account could basically suck that in. So while Lambda layers allow you to share code across Lambda functions, Lambda extensions extends the Lambda service to enable better integration to external tools. So we will be talking about Lambda extensions next. So this was recently announced. There were two new services related to Lambda that have been announced recently, and extensions is one of them. So similar to how you can extend Lambda runtimes by bringing your own custom runtime, which leverages the Lambda runtime API, you can use the extensions API, which provides a way for tools to get greater control during function initialization, invocation, and shutdown. And as you can see in this screen, the extension can also have access to more logging information that's built into the Lambda service. So to see the power of Lambda extensions, I want to look at this life cycle. So you can see that the extensions itself initializes first and shuts down last. So this allows you to put custom code at the very beginning stages of the function and after the code runs. So before Lambda extensions, it was not possible to have custom logic outside of just the Lambda itself. So even with Lambda layers, like that code would still be basically pulled down when that Lambda container kind of kicks off and runs. So again, this is really big that you actually can write custom code at the very, very beginning and at the very, very end of the stages. So if you see in this screen, there's three different initiation tasks now. So there's an extensions init, runtime init, and the actual function init. So again, this kind of creates an order where the extensions and the runtime can perform various tasks, but before the actual function code runs. And then during the invoke phase, this is very similar to what was going on prior to extensions being announced, but the runtime requests the invocation event and invokes the function handler. So in addition, the extensions can now request lifecycle events from the Lambda service, and you can run logic in response to these events. So the extensions is essentially just running at all times in the background. And then in the shutdown phase, and this would occur, after there's a certain amount of delay since the last Lambda ran, but you'll basically be able to gracefully shut down. So your extensions would get a notification from the Lambda service that, hey, this function hasn't been running in a while, so now we're going to issue a complete shutdown. So that would allow you to stop any logging agents that you may have running, or just do whatever type of cleanup that you feel that you would need to do with that particular extension. So what are some use cases of using extensions? There's 4 listed here, but again, since you can put custom code in those, at the very, very start and the very, very end, that I'm sure that we could really get creative, and there's probably a lot more use cases than these, but just to highlight a few. So you can grab information before, during, and after the function runs, like what we were saying. It's a lot easier to add, either third party or create your own logging outside of the function code itself. So the logging framework that Aaron was mentioning, that's not only could you maybe put that into a Lambda layer, but you could build a Lambda extension around that potentially as well. Another great use case is grabbing either configuration or secrets before running the function itself. So this would make all subsequent runs of your Lambda a lot faster if you were basically able to just pull down, various secrets one time and then have that available, across the entire process. And you can also monitor runtime activities and alert as needed. So that was Lambda extensions. And now next I want to discuss another new service called CloudWatch Lambda Insights. So this is a little bit different than CloudWatch Insights. It's specific to Lambda. But this is another new feature, and it is now generally available. That was recently announced last week at reInvent. All right, so while Aaron talked about application logs, Lambda Insights helps with getting more performance information from Lambda. So you can, for example, you can better monitor memory cost and latency drivers over time. So it can provide more data to help you make intelligent decisions on how to optimize your functions. So this could include, maybe finding memory leaks, expensive functions, monitor what happens to performance after changes are made, and a lot more. So when you enable Lambda Insights, and I'm really sorry if you can hear my dog barking in the background, but he is just not stopping. So when you enable Lambda Insights, you'll get access to two predefined dashboards. So these both include all the new performance metrics that come with Lambda Insights. So there's a multi-function dashboard and a single function dashboard. I want to show you what these look like. So the multi-function dashboard is where you'll see an aggregated view across multiple Lambdas. And we have a little search utility that you can search and filter by name. Soon you'll be able to filter by tag as well. So this dashboard gives you the information to make informed decisions about better Lambda optimization over time. It also integrates with CloudWatch logs, so you can easily navigate and see additional data. So in a couple slides, I'll show you what the actual raw log file looks like, but all the data that you see in the dashboard and in the next one that you'll look at it, all that data that would go into giving you the information to build that, it also gets sent to the CloudWatch logs. So then you could ship that off to your Elk stack or wherever if CloudWatch logs is not your main, logging area. So that can be really powerful, and we'll look at an example of that in a second. So the single function dashboard, so this can help you view the performance of a single function. So for example, in looking at the memory usage dashboard, so that's the one on the bottom left, it looks to be that there could be a memory leak going on with this particular function. So you see, after each Lambda invocation, it kind of stair steps up and up and up. And then maybe when a new container gets created, or maybe something within the Lambda application code itself releases that memory, but you just see it just drop, and then it keeps going up and up and up again, then it drops. So before Lambda Insights, we really didn't have a great way to see information like this. So it's pretty clear that you can maybe optimize what the application code is doing with memory, and then maybe even get like a smaller Lambda function, for example, to save some money. But this is just an example of what you would see with that single function view. So like I said before, all the data that goes into this, like the amount of CPU being used or memory and a bunch of other fields, also get sent to a CloudWatch log group, and it's a special group. So like I said, you could ship these off to somewhere else if you want to, or you can use CloudWatch Insights. So that's again a little bit different than CloudWatch Lambda Insights, but there's a way that you can search over these and maybe create your own graphs if you want to. But a few things to highlight: so you get a request ID. So if your application is also logging this request ID, like what was said earlier, then you could potentially have your application logs marry up with these new Lambda Insight logs. And if there's like a long running process, for example, like a long running request, then you can see, okay, well, how much memory was the Lambda using at that time, or how much CPU did that particular request use? And now you'll have access to that level of information. So that's the real power that comes from Lambda Insights. All right, so I know that we maybe went through a lot of detail pretty quickly, but there's a ton more information out there and various blogs and developer guides. But I wanted to finish by highlighting a few recent announcements that were announced last week at reInvent. So I alluded to this a little before, but I thought the best way to maybe do this was to show a Twitter poll released by one of my colleagues, Chris Moons. So he asked, I think this ended over the weekend, but he was just asking, Twitter basically, what has gotten people most excited about the 4 Lambda announcements. So these include per millisecond billing. So the previous minimum billing unit for Lambda was was 100 milliseconds. So if you had a lot of Lambdas, for example, that were running at 20 milliseconds, and now after this now per millisecond billing was announced, that you could potentially be paying 20% of the Lambda bill that you were before. So I know personally, like when I was creating systems that maybe we were pulling information off of SQS, for example, there's a lot of times that the Lambdas were just running so quickly that no matter if it was taking 5 milliseconds or 99 milliseconds, they were all being charged at that 100 millisecond level. So now, since we have per millisecond billing, it really opens up to make Lambda cheaper, but also like cost isn't as much of a concern when you're creating Lambdas that that are going to run really quickly. So I can see why this was voted as most exciting. So next, we also announced larger sizes for Lambdas. So we have 6 cores and 10 gigs of memory now. So I think there's some good excitement around that. We also announced, which this is my personal favorite, is container support for Lambdas. So you can build containers that interact with the Lambda runtime, and you can deploy these directly to the Lambda service. So unfortunately, I've been super busy the past week, so I haven't really had a chance to play around with this too much, but I am really excited about this, and I'm really looking forward to getting my hands dirty with it. And then finally, Lambda Insights. We talked about this. So Lambda Insights itself has been around for, I think, about a couple months now, but it was in preview. And we've officially made it generally available as of last week as well. So that just provides, maybe a little bit more support once it's out of the preview mode. So again, I think that a lot of people are excited about that, and the reason that maybe that percentage is so low is because it has been around for a while, and I think maybe people weren't excited as the other ones just compared to just be coming from preview to GA. But I know that Lambda Insights, there's a lot of excitement around that feature. All right, so this is all that I had to go over. So I'd like to turn it over to Jerry now. He's going to go through the demo for the login solution that Aaron was talking about before. So sorry for my technical difficulties there and any dog barking, but I really enjoyed speaking with you today.
All right, thanks, Josh. I'm going to turn my video on real quick too to introduce myself. Hi guys, I'm Jerry. I'm a senior consultant at Big Compass, and let me share my screen real quick. And I work primarily with serverless, and today I am going to be showing you guys I have the pleasure of showing you guys a project that showcases all of the best practices that Aaron talked about earlier. Just like in the architecture diagram we were looking at in this slide, we're going to have a producer side of things and a subscriber side of things. So I'm just going to jump right into showing what our producer side looks like in this demo. So this is our project for the producer side. This is a serverless Node.js project. And this project is sending out various logs to an elk stack instance, which is what our consumer side consists of. So this is a pretty simple example project that just hits a Pokemon API and passes data between 3 different Lambdas. So it starts at this catch Pokemon data Lambda, which is an API gateway endpoint that proxies over to this Lambda. And this catch Pokemon API Lambda passes data over to this fetch Pokemon Lambda here. And that passes data over to the process Pokemon data Lambda here. And like I said, this demo follows many of the best practices that Aaron mentioned earlier. So as far as standards go, all of our logs are going to be using a custom logging framework that logs out with a JSON object to send out to the subscribing side. So all of our logs are in JSON. All of our messages, we try to make all of our messages informative and include as much metadata as possible, but not more metadata that we need. So in some cases, we're attaching a Pokemon name to our JSON object. In some cases, we attach a Q URL, as you can see here. And we even attach a little bit more information in certain areas where it makes sense to. So we're attaching like a full Pokemon data object in this log here, as you can see. So we're sure to make our messages as informative as possible. And you also might have noticed that we're attaching a request ID here at the top, and this actually relates to the Lambda invocations request ID. And we do this so that each Lambda invocation has a direct ID that's associated to it, so that if there's ever any issues that come up, we can actually find the exact Lambda invocation where that issue happened. And then you also might see that we're attaching this job ID to all of our logs as well. And this job ID relates to that reference ID Aaron mentioned before, where you can trace everything from start to finish. So this job ID gets logged from the beginning all the way through to the very end of our lambdas. So you can see we actually use the same job ID between the catch Pokemon Lambda, the fetch Pokemon data Lambda, and the process Pokemon data Lambda. And later on, here in a second, I'll show you guys how we're able to like use this job ID inside of an elk stack instance to actually look up an error that happens. I forgot to mention, these lambdas will actually be throwing mock errors so that we'll be able to really see some good examples of error handling in all of these lambdas. So actually, when talking about error handling, that's one other best practice that we're trying to do here. So all of our errors route to this handle error function, and they log out the error message, but they also log out the error itself. And what our logging framework does with a full error object is it parses out the stack trace and the name of the error and actually formats that nicely in our JSON object. So this is a good example of making sure you include dynamic error messages in your error logs so that you're able to see full stack traces and things like that. So at this point, you might be wondering what's actually under the hood here, because we're looking at this logger object everywhere, but so far it might look like just magic. So I'm going to switch over to this logger file here. And this logger is an instance of the logging framework Aaron mentioned earlier. We created this logging framework to help with logging out to external endpoints asynchronously within your serverless functions. This logger takes in what we call transports. And so transports are used to easily send out to various destinations at specific log levels. So for example, this transport will log at the debug level and above, and it's going to log out to the console. This transport logs out to an SQS queue. And what this is doing is at the info level and above, our logger will send out all info level logs and above to an SQS queue, which will route to an elk stack instance at the end. This logging framework also allows the means of having default properties in your logs. So every single log that we have will include a project name, as you can see here. So all of our logs will have that in the JSON object. And they can also have dynamic properties. So we have a function called timestamp here. And what this will actually do in the background is attach a timestamp property to each and every one of our logs. And then we also have a couple weird looking properties here that are just formatting Boolean values to ones and zeros. And we're doing that to help with a specific use case in our elk stack instance. So that's everything to really important about logging and our producer side. I just wanted to show how we're really using all of those best practices Aaron talked about in action. But before I move on to the consumer side, I do just want to show just where our logging framework is. As Aaron mentioned, this logging framework is public to use. It's a JavaScript/TypeScript library, so you can use it in any JavaScript or TypeScript project. It is public. It's not on NPM necessarily, but there are installation instructions on how to use NPM or Yarn to install it into your project directly from our public GitHub repo. And like I said, it has a good bit of current features such as sending logs out to SQS. You can send logs via HTTP, and you can actually define your own custom destinations to send to. And there's documentation in this README on how to do that as well. It includes default log levels such as debug level, info level, warn level, error level, and critical. And you can also define your own custom log levels as well. And the main reason we made this library, because there are libraries out there that are very similar to this, but the main reason we made this library is because it helps with logging from serverless functions specifically. One problem with logging asynchronously to external endpoints in a serverless function is if you don't wait for those asynchronous processes to finish before exiting your serverless function, they might not actually make it to their destinations. We've actually experienced that before, where we are sending logs out to an SQS queue and we exit the function before the logs before it even makes it over there, and the logs never arrive. So we made this library both to have a very nice format and be easy to use, but also to help with that crucial difficulty of waiting for your logs to finish. So in all of our Lambda functions, we simply can call this await logger.flush at the end of our Lambda function. And that simply waits for any asynchronous logs to finish sending before exiting the function. And this might be something we look into Lambda extensions with later. You know, maybe Lambda extensions could call this logger.flush at the end. That's actually a new thing to me, Josh, so I'm excited to look into that with this library. Anyways, so like I said, this is available on GitHub. If you do want to look at it, we would love feedback and anything like that as well. Or if anyone were to try to use this and find bugs, we would love to know about them. But we'll be sure to include that in the notes. I'm going to move on and just take a quick look at the consumer side of things before I run the actual demo. On the consumer side, we're using Elk Stack, which for those of you that don't know what Elk is, it stands for Elasticsearch, Logstash, and Kibana. So this is a Kibana dashboard, and we're actually, this just has a few simple visualizations of some logs about our Pokemon data. So the way we set this up was to use AWS CloudFormation to create an EC2 instance that houses our Elk Stack. And for those of you that don't know what CloudFormation is, it's an infrastructure as code framework that AWS provides for provisioning any kind of resources, for the most part, that you need to provision. In our case, we wanted to create an Elk Stack, that houses or an EC2 that houses our elk stack instance. And we needed to create a way for sending logs to an SQS queue that our Logstash service pulls and reads logs in from. So one crucial thing we did here was we set up our EC2. And this is the code we used to set it up. This is inside of our CloudFormation template. Then further down, we actually created an SQS queue and we reference it within a configuration file in our EC2. And in that way, we were able to use CloudFormation to basically set up an elk stack instance and all of that routing logic entirely all through CloudFormation. So without further ado, I'm going to go ahead and run a quick demo. So I'm going to run a script that actually sends new logs over to our elk stack instance. So this is going to simulate sending a bunch of requests to this catch Pokemon API endpoint, which will send messages to each Lambda after that. And it will also be throwing errors like crazy in each one of these. It'll be throwing mocked errors in each one of these. So I'm going to go ahead and refresh the data. And we already have some new data in here. And so the reason we're so passionate about having good traceability in our logs and good visibility is, for one, just with these simple dashboards, we're able to see that in the last 15 minutes, we've had two errors of this error message occur and 3 of this error message. So this is an example of good visibility in your logs because you're able to quickly and easily see what's going on, at a high level with your application. But not only that, you also need, as Aaron mentioned, good traceability in your logs. So I'll show you what that means now in action. Let's say I wanted to look up this weird generic error message number 142 that's happening 8 times. I could grab this message and move over to the Discover page in my elk stack. And I could first look up this error message here. And now I'm able to see all these different logs where this error message is being thrown. And like I said earlier, we were logging out a job ID for to act as a reference to our entire job end to end. So I can also now look up this job ID. And this is a good example of being able to trace your entire process end to end. So now that I've looked up this job ID, I'm able to see from start to finish. We started the catch Pokemon job. We successfully sent the caught Pokemon to the next step, started the fetch Pokemon data job, and that succeeded. And now we're getting here, start process Pokemon data job, and that's where the error occurred. So we're able to see the full life cycle of this job and see where exactly the error happened. We have our stack trace and everything like that. So that's really all I had to show for this demo. I hope it's good. It was kind of a good example to you guys of some of the best practices Aaron was talking about. With that, I'm going to go ahead and stop sharing and pass it back to Aaron really quick. So to you, Aaron.
All right. Thanks, Jerry. I'm going to share just one more slide. We're getting to the end here. And we just showed the demo. Next steps, if you want to clone the Big Compass logging framework, it'll be in the slides here. We'll post the slides. We'll post the recording as well. So you can go to the link right here on this slide or go search for Big Compass on GitHub is where that lives. And Stephanie will be sending out some wrap up with that link also. So thank you very much for attending. Hope you learned a lot. Feel free to contact us if you'd like to present at the All Things Integration meetup, or if you have any questions about using our repository, or again, want to talk about anything integration related. Great seeing everyone here and looking forward to seeing you in January.